Chapter 4, Section 4 is on scatter plots and lines of fit. So this says determine whether each graph shows a positive correlation, a negative correlation, or no correlation. A positive correlation means in general, as you move to the right, the points are going up. So this is a good example right here of a positive correlation. You can see as we move to the right, in general, the points are moving up. They don't have to be like a perfect line, but you can tell the pattern is that as you go increasing on the x-axis, it's also increasing on the y-axis. So we'll go ahead and write positive here. Okay, now this, you can tell there's not really a pattern at all. I mean, there's high points back here, over here, there's low points back here, over here. So this is being an example of no correlation. And 3 is an example of a negative correlation, because in this one, as we go right on the x-axis, the y values are decreasing. So when you have a general increasing pattern, it's positive. No clear pattern, no correlation. A general decreasing pattern, it's a negative correlation. Now let's look at the other part it says. If there's a positive or negative correlation, describe its meaning in the situation. So this is where we need to look at what the graph is actually describing. So it says calorie burned during exercise. So this represents the amount of time spent exercising, and this represents the number of calories that are burned. So always start by describing what's happening as the x-axis increases. So as the time spent exercising sorry, I ran a room there. That's exercising. As the time spent exercising increases, so I start every time, no matter whether it's positive or negative correlation, start by talking about how as whatever the x-axis represents increases. And in this case, we see that as the x-axis increases, so do the y values. So number of calories burned, we know it's calories burned based on the title. So the number of calories burned also increases. Shocking, right? The more time you spend exercising, the more calories you burn. The more you know. So this one, we don't have to write anything, but that doesn't mean this doesn't mean anything. So again, you're not instructed to write anything, but I want to explain what this actually tells us. So this is talking about library fines. This is the number of books borrowed and the fines. So there's no clear relationship between how many books someone borrows and how many fines they owe. So in other words, this data tells us that it's not more or less likely that someone is going to have to pay fines if they borrow more books. So the more books you borrow, no clear pattern. So there's no clear relationship between the number of books someone's borrowed and the number of fines they owe. In other words, people who borrow a few books or a lot of books, some of them return them on time, some of them don't. Okay, let's look down at number 3. So again, this is a negative correlation because we see overall as x increases, y decreases. So I believe this is the weight that they are lifting. They're not talking about the person's weight. So they're talking about weightlifting. This is how many pounds they're lifting. So again, we always start by saying as this increases. So as the amount of weight being lifted increases. As the amount of weight being lifted increases, the number of repetitions the weightlifter does decreases. I promise I will give you more room to write when I put this on a quiz or a test. And for any of you who've lifted weight, and probably those of you who haven't, this makes sense. If I pick up a 10 pound dumbbell, I can probably do a lot of lifts and curls with that, with one arm. But I pick up a 40-pound dumbbell, I won't be able to do as many repetitions with that one if I'm just going till I can't anymore. Okay, number 4. Now we haven't talked about what kind of correlation it is. So this one is less scattered in some ways than these two look. But again, if you look at the overall pattern, it's heading up. Now this is not as steep of an increase as what we saw here, but still the overall pattern is that it's increasing. So we'd say this is a positive correlation. So let's see what they're talking about. Car dealership revenues. People who sell cars, how much money they're making. So this is the year. So we're just looking at how things change over time. This is their revenue. Okay, so as the years go by, or as the years increase, or as time passes, the amount of revenue earned increases. Okay, let's do one more with this, talking about baseball tickets. So this scatter plot right here shows the average price of a Major League Baseball ticket from 1997 to 2006. Determine what relationship, if any, sorry if it seems a little fuzzy, it's actually not the camera, as you can tell on my handwriting. The copy just isn't quite as crisp as I would have hoped. But anyway, so the scatter plot shows the average price of a Major League Baseball ticket from 1997 to 2006. Now, if you see what they said up here, it said scatter plots, which we've been talking about, and lines of fit. One thing mathematicians will do is they'll gather data, and then they will figure out a line that is the best fit for that data. That way they can then use that to help predict what will happen in the future. Okay, so part A is what we've been doing on 1 through 4. There's certainly a positive correlation here. So as years increase, the ticket price increases. No shocker there. So as years increase, ticket prices increase. Now, it says use the points 1997, 13, 2005, 22 to write the slope-intercept form of an equation for the line of fit shown in the scatter plot. So we're going to find the equation of this line by using these 2 points. So remember what these mean. In 1997, the average MLB ticket price was $13. In 2005, the average ticket price for a baseball ticket was $22. And it says around values in the nearest hundredth. Okay, so they gave us 2 points. We got to start by finding the slope. So y2 minus y1 over x2 minus x1. 22 minus 13 is 8. 22 minus 13 is not 8. It's 9. 2005 minus 1987, that's 8. Okay, so that's our slope, 9 over 8. Then we can use either of these 2 points to put them in the point slope formula to then find it. So I'm going to have to use some of the space down here. I know this is part C, but just don't give enough room. So I'll do y minus 13 equals 9 over 8 times x minus 1997. And please feel free to use a calculator here. So I first need to distribute the 9/8. Y minus 13 equals 9/8 x minus, let's see what that is. Oh, I don't have a calculator up right now. One moment. Thought I did. Calculator. Here we go. Oh, it's so big. Oh well. So 9 over 8 times 1997. Okay, and they said rather than year's hundredth, so we'll say 2246.63. Okay, so there it is. You can see it behind there. Okay, and then after that, we need to add 13 to both sides. Okay, so I need to make this negative. I forgot to include that part. Okay, so now it's negative, and I add 13 to it. So negative 2233. So we finally have it. Y equals 9 over 8x minus 2233.63. All right, so now we have the equation of this line right here. And again, the benefit of finding this equation that fits the data we have is we can now predict what's going to happen in the future, because we're saying, all right, we figured out the pattern of how ticket prices increase over the past 8 or 9 years. So now we can use that and say, if it continues in the same pattern, how much will it be 3 years from now in 2009? And I just mean 3 years from the last point of data we got, not from our present. So to do that, we will just plug 2009 in for x. And again, we will let our calculator be our guide on this one. So I will clear all of that from before. 9 divided by 8 times 2009 minus 2233.63. Okay, so we'll round to the nearest penny, basically the nearest hundredth. So they expect that it will cost $26.50 on average for a Major League Baseball ticket in the year 2009.